All right, so leading into exam one, we looked at the basics of risk, the basics of risk management, and we also spent some time talking about insurance, okay? What it means for an insurance contract to be, or what it means for a risk to be ideally insurable. I asked you a couple of questions about that. What are some of the things that we'd like to see in an insurance contract, so like a pure risk transfer. But most of these, we're kind of focused on what the firm would want to look at, okay, when they're offering policies, or what we as risk managers might want to think about if we are looking at an insurance policy for our firm for whatever reason. Okay, what we're going to spend some time with today is we're going to look at the individual purchasing decision. So why do individuals buy an insurance policy? Okay, and in that we're going to keep the ideas of risk we already have. We're going to bring in something that's new to this class, which is just basic utility. Okay, very simple utility theory. And then we'll use that to show why, even if it's a negative NPV project, so something we can't make money on, why people would still purchase insurance. Okay? So to think about it here, let's use this loss distribution, something that's not new to us, and we'll reach into our kind of statistics, our bag of tricks of statistics, and say, all right, well, if we're going to offer insurance for risk like this, the two things that we can work with at this point in time are a simple weighted average, okay, and the standard deviation. So we already know how to calculate those. So what do we expect the average loss to be for this distribution? It would be $100. What was deviation? It would be $300. And so these are things that we can do, that we can calculate, and it's fairly straightforward. So back to the original question, what do we want to charge for this? Well, if the average is 100, if we're a firm, we probably want to charge more than $100. We ignore any other types of income, any way to kind of subsidize this loss, say with investment income. We probably want to charge more than $100. Why? Well, we're not going to make money any other way. Will we make money on some years? Well, yeah, because some years they won't have a loss. But on average, you're going to lose money if it's less than $100. Okay. So what must we charge to make, in this case, an underwriting profit? We must charge something greater than $100. This is ignoring any long tail pipeline or overhead costs. Just on underwriting, it has to be at least $100, right? Because we expect it to be that. Well, who would buy that? Because it wouldn't make sense, right? Going back to the NPV perspective, it would not make sense. It's not a positive NPV project for the potential policyholder. So, no, it does not represent something that a potential insured, so someone looking for the policy, doesn't represent something they can make money on. So, it makes sense they wouldn't buy it, but people do buy insurance. Okay? Even if they're not required to buy insurance, people still will purchase insurance. Or they'll purchase warranties. Not saying those are the same thing, per se. So why? Why do people pay more than the expected loss to cover that expected loss? So a couple other things we can use to describe this. It doesn't have to be in a losing scenario, right? It doesn't have to be in a losing scenario. Let's say that we have two lotteries here. Two lotteries. One, it's a 50-50. You win nothing or you win $1,000. We expect on average to win $500. Another one, well, depends on some X value, but it's a 100% chance. So it's a given that you win this lottery. So my question to you, for you to think about, what should this X value be for you? It's different for everyone. What does it need to be so that you're kind of indifferent, to you where it's about the same? So why don't we start at $500? If you're okay with $500, a guaranteed $500, or you're indifferent to playing that game where you could win 1,000 or zero, but it averages 500, if those two are the same to you, we would consider you risk neutral. Because with one option, you have risk, you have uncertainty. The other you do not, but all you care about is the expected, in this case, win or the expected value. We oftentimes say that businesses live in this realm of risk neutrality. So we assume that firms are risk neutral. What if you're like, well, yeah, I could win 1,000 or I could win nothing. I will play this other game if it's $300 because I know I'll get 300. I'll happily take a certain 300 over an uncertain 1,000. You would then be considered risk averse. You'll forego some of that expected gain. You're essentially, on average, you're paying $200 to know that you'll get 300. You're losing out on, quote unquote, on average, you're losing out on $200, but you know you will always get 300. Most individuals, financially, especially with some large losses, we see them tend to be risk averse. See that they tend to be risk averse. On the opposite, if you say it has to be more than 500, then you're risk seeking. You like that. You like that gamble because you know you can make 1,000. So maybe it has to be $900. Maybe it has to be 1,000 because you just want to gamble. There's nothing wrong with that. And we can see individuals be risk averse in some areas and risk seeking in others. It's not uncommon. And the same individual can change their risk aversion over time. Okay, so it's a risk preference. So we're seeing here that in two instances, that is like simple averages or simple even deviations don't really quite help us. Okay, don't quite help us. But let's look at an even more extreme mathematical example, okay, called the St. Petersburg paradox. So we're bringing in another kind of gambling type game here. And we're keeping in the back of our mind, why would some people behave in a certain way? The numbers dictate one action, but people do another. Okay. So here, we have a game. We start out with $2. We flip a fair coin. Every time that fair coin lands on heads, the amount doubles. So 2, 4, 8, 16, 32, so on and so forth. The amount doubles until you flip tails and then you get whatever's in the pot. So if we were to try to attribute an expected value to this, we will get a series that does not converge. So there's a 50% chance from the first go. But it's conditional, so it's a 25% chance, then 12.5, then 6.25, and so on and so forth. Or a better way, 1/2, 1/4, 1/8, 1/16. So we have this infinite series summation of 1. And I guess I kind of spoiled it, but I said it was an infinite series. So does this sum converge to an actual value? The answer is it doesn't. Okay? It keeps going to some infinity. Which infinity? I don't know. But it keeps going to a infinity, or an infinity. So the expected value of this game is all the money you could imagine. Would you or would anyone really bet all the money they could imagine to play this game? Probably not. So we've got three kind of behavioral aspects here that numbers don't, right now the numbers don't help us with. The first one, people buy insurance products, and that's where we're going to kind of live. But the first one, they buy insurance products, even, they'll pay more than what they expect to lose. That doesn't make sense. The second example, we had 2 lotteries, and some people would take less than the expected value, not all, but some would take less than the expected value to get a certainty. Okay, so they're losing money on average. And then people won't pay an infinite amount of money to play this game that's worth an infinite amount of money. Okay. Why? Well, maybe we're missing a component here. Maybe there's some way we can take all these and synthesize them, create a nice little simple model of these behaviors to explain them all. And utility helps us with that. Okay? So utility, as we define it here, is just a measure of how happy or satisfied you are with your consumption, with what you have. Very simple way to say it is the utility you garner from wealth. Because you can use money to buy most things, not all, but most things. And since this is a finance course, we're going to focus more on dollars and cents. So how satisfied with you are you with your current level of consumption? How happy is the money in your pocket making? So we're going to examine utility as a function of wealth. Okay? And we'll use two functions to explain two different behaviors. So we're trying to think about a relationship between risk aversion and then bring that back to the demand for insurance. Or maybe why people would not pay the expected value of a game to play that game. Now, we can use utility to map out a risk-averse individual. So what do we assume about someone who is risk-averse? Okay. What do we assume about someone who's risk-averse? First one, if they're risk-averse, if they're a risk-averse consumer or individual, they always will take an extra dollar. If there's zero transaction cost, someone can snap their fingers and, oh, there's another dollar in my pocket. They will take it. Most consumers will do this, whether they're risk neutral or risk averse. So they'll always prefer more wealth to less. However, as their wealth increases, that next dollar doesn't mean as much as the last. So in other words, they experience diminishing returns. And we can think of this as proportionality of wealth too. Not quite the same, but we can think about it as proportionality. $1,000 to any of us in here, we'd probably be quite happy with that. Sure, if I can snap my fingers and we can all get $1,000 just right in our pocket, I would do it. Take Jeff Bezos, for example. He would still take an extra $1,000 if there were no transaction costs. If he didn't have to take time out of his busy day to do that, he would take it. But it would not mean nearly as much to him as it would to anyone else in this room or anyone else on earth right now. So we can think about it as proportionality as well. Okay, but this is a bit deeper, but that's another way to think about it. And we're not getting as much back. It doesn't mean as much to us because we already have plenty. What's another dollar? So if we have $10,000, then another dollar doesn't mean as much as if we just only have $1. Okay? So we do see this diminishing return. So if we think about this mathematically, what this means, if we were to graph utility as a function of wealth, we're going to see it increase always, but at a decreasing rate. So it's going to have some curvature, like this. And in fact, the example that we're working through today, we will come back to each of these points here. But all I want you to get from this now, we have our utility, which is a function of wealth, on the vertical axis. And then we have the actual wealth on the horizontal axis. And what do we note about this? Well, yes, as we move along, as we increase wealth, we do see utility increasing. It is continuously increasing, but not at the same rate. Look from point 0 here to D. That's a pretty high slope. Then from point B to A, not so much. So that delta decreases. Now, the form that we're going to be using in this class, we're just going to use the square root function. In your math classes, you've probably seen y equals square root of x. Looks very similar to this. And that just helps us visualize. It's not like someone says, oh, the square root of x, that is going to, or the square root of wealth here is going to explain risk-averse people and why they purchase insurance. No, it just so happens that we need it to be increasing, but at a decreasing rate. The natural log function does that as well. Okay. So this is just kind of a nice little mathematical tool or formula that gives us this. Okay. If you prefer numbers, have that here as well. So let's test to see if the square root function increases with wealth, but at a decreasing rate. That's what a risk-averse person does. So does this formula we're using here, excuse me, this, we say it's a function, does this function map out what we assume? And if it does, then we can use it to explain behaviors. Well, if we go from $4 to $5, our utility increases by 0.236. So the square root of 4 compared to the square root of 5, what's that delta? 0.236. That same dollar from 64 to 65, our utility here, again, the square root of each of these, the delta is only 0.062. So it's less. So mathematically, this fits because the first rate of change, the first derivative is positive, but the second one is negative. So great, that works. So let's take it, look at someone that could experience something they may want to insure. So maybe low frequency but high severity. See where they are without insurance, where their utility is on average. See where they would be with a very, very nice and fair, actuarially fair premium. And then we will see that they will pay more than that fair premium, the actuarially fair premium, their expected loss, and still increase their utility. Okay. Well, let's take Ray. And again, the graph is actually depicting all of these things that we're working through, and we'll come back to it. But let's take Ray here. He has initial wealth of $64. He has a 25% chance of a $60 loss. So let's see, 25% of 60, that's $15. He expects to have $49 on average. He's either going to have 64 or 4, but on average he's going to have 49. So let's see what we expect his weighted utility to be. So just like we calculate expected loss, expected value, this is the exact same thing, except that we're using utility. Keep in mind that the dollar amount is not, right now for a risk-averse person, is not the utility. It's the square root of that. So you're calculating these probabilities and utilities, make sure the probability is separate from that function. In other words, don't take the square root of the probability and the dollar amount. Okay? So I have that here. So we're taking the probability, he's in that loss state, so it's 25%. And what's he left with? 64 less 60, which is $4. Okay, so the common mistake I will see is, just putting the probability within the function. So with no insurance here, so that's what this superscript is standing for. With no insurance, it's a 25% chance he has utility of 2, 75% chance he has utility of 8. We expect on average his utility to be 6.5. Okay. So that is Ray's baseline. With no way to transfer at this point, his baseline utility is 6.5. Utility is a measure of his satisfaction, how happy he is. He will always want to maximize that, we assume. We assume most people want to maximize happiness. Okay? He will make any choice that brings his expected utility above 6.5. He will forego any choice that drops it below 6.5. So this is kind of his benchmark here. This is where he is with his current decision-making process and potential outcomes. So let's say that a very, very benevolent insurer says, hey, I will insure this loss for what we'll call the pure premium. So it's an actuarially fair premium. All that means is that it's equal to the expected loss. Is this individual or this insurance company going to make money underwriting return on this? No, not on average. Some years they might, but on average they're just going to net even. Okay. They're going to charge him $15. So your pure premium is just the expected loss. Okay. They're going to charge him $15. to cover an average loss of $15. Ignoring any other sources of income, there's no way they can make that back up. It was a very, very nice thing to do. So he can pay $15 and will be completely indemnified. We'll assume no deductibles, no transaction costs. Boom, he gets the money right then and there. So what is his utility? Well, no matter what, there's no uncertainty, no waiting. He's always going to have $49. So 64 less than 15. So the square root of 49 then would be 7. Now, if we want to focus on, I guess, semantics here, what is really happening is that he does have two loss states, or a loss and a no loss state. He starts out with 64, pays them 15, and he's done. Or he starts out with 64, pays them 15, loses 60, they reimburse him for 60, and he's still back to 49. Okay, so that's what's really happening here. But the outcome is the same. No matter what, he has the same amount in his pocket. So will he make this decision? Has he increased his utility over 6.5? The answer to that is yes. So the answer to will he make this decision is also yes. And most people would make this decision anyway. If you knew exactly how much you expect to lose on your auto or homeowners, and you're charged just that, why not pay it? Assuming no deductibles? Sure. But what if some profit needs to be made? God forbid a business try to make a profit. So will he still purchase? Like I'm telling you, I told you before, let's put my money where my mouth is. If we charge him $1 on top of that, so we'll have a loading charge of $1. We'll load on top of the expected loss. Will he still pay it? So what happens now? He has the 64, pays 16. Even if he has a loss, it's out of there. It's covered. No time value to worry about. It's magic. So he's left with $48 in all scenarios. He's still above 6.5. Will he pay $16? Yes. So he will pay more. Now the interesting question, and the last question we'll ask using this kind of method here, is how much would he pay? So what value here is going to set him all the way back to 6.5? Because that's where he'll be indifferent. So what unknown, so this X value here, is going to set this utility to 6.5. So if we do that, we set it equal to 6.5 here. So this is our unknown. How much can we charge? Work through some simple algebra here. Square both sides. And we get it. We could charge up to, we are the insurance company, could charge up to $21.75. So leaving him with $42.25. And he would be at 6.5 utils or utility. So that is $6.75 that the insurance company has made as profit, while still letting Ray stay at his original utility. So if we go back to the graph, again, this is all Ray. Now again, it's not like every single period he's just somehow oscillating back and forth on this. No, he's at one point at any given time. Prior to insurance, he goes back and forth with incomes of 4 and 64. So that's points D and A respectively. It's either one or the other. So it's the 25% chance he's here, 75% chance he's there. His expected utility with no insurance, point E, is 6.5. At that point, he is below the map of his utility function here. Given these other options, it's not ideal. So if he has the option for anything above utility of 6.5, he will choose it. He will maximize his utility. At that point, he's indifferent. Well, he has options from the insurance company, all the way from C to B. So B is the pure premium, the actuarially fair premium. Point B is, where his utility was 7. They're probably not going to offer him that. But anything in between B and C, as we slide from B to C, yes, it becomes a slightly better deal for the insurance company. But he is still happy with any decision about that line. So he will give up more money. The insurance company can make money, and he can still maximize his utility because of his risk aversion. And this is why people, even without being required to purchase insurance, or warranties kind of work there too, people will do that. Because they are risk averse, they will pay extra money to mitigate uncertainty. They'll take a known over an unknown. All right, so questions about Ray. Let's go back to the graph, I think. Questions about Ray and his decision-making process here. So we assume Ray is risk averse. So in the worksheet, you won't be recreating the graphs here. If you want to, that's fine. The worksheet that I'll give you and what you'll see on the exam, we'll be running through what's their expected utility without insurance, what would the pure premium, in other words, the expected loss, what would that be? And then what's the maximum amount that they would be willing to pay on top of that pure premium? All right, so that's risk aversion, and that helps explain why individuals will purchase insurance. However, what about risk neutrality? And the reason I want to spend some time talking about risk neutrality is because, as I said earlier, we assume firms are risk neutral. This is a risk management class. We're not always going to be talking about individuals. Okay. Not that that's not important, and not that businesses aren't created by individuals. But we're going to talk about risk neutrality. We won't spend time on risk-seeking behavior, but I do want to talk about risk neutrality. Now, the problems we're going to go through here, because of their simplicity, it won't be something that you see on the worksheet. This is just to kind of iron out the details and provide, some other explanations for, why a firm will be risk neutral or why they would behave as if they're not. So no models are perfect. So our two assumptions here, the first one's the same. Risk neutral, you'll still save that money. Okay. In fact, you're always about increasing or maximizing NPV. You're always about maximizing. What's different for you, if you're risk neutral, that uncertainty doesn't weigh in as much. Each new dollar that you could potentially get is worth just as much as the last. There's no curvature. So if we were to graph a risk neutral entity, have utility of wealth on the vertical axis and wealth on the horizontal, it will be a straight line. Every dollar gives you one more utility, one more UTI. 10 gives you 10, 20 gives you 20. So it's completely linear. So there's no decreasing. So first derivative is positive, second derivative is 0. No rate of change on that second moment, or second part. No diminishing returns. So we'll map this just by saying your utility of wealth is equal to your wealth. It's a constant rate. Derivative of that is 1. So let's take Ray and say that Ray owns a business. So now we're looking at not Ray, but Ray's firm. And we assume that firms are risk neutral, so we can use this to map out his decision, or his firm's decision, on purchasing an insurance contract. Now his firm has 1,000 times the wealth and losses to match. So his firm has $64,000, 25% chance to lose $60,000. So again, this is, I say similar, it's a multitude. or multiple. Let's do the same thing. Where is his firm now as far as utility? Do a weighted average, $49,000. Here his utility is the same as expected value. It's a one-to-one mapping. He expects to have $49,000 at the end of the period, always. Well, not always, on average, excuse me. So if he's charged the pure premium, so the expected loss of $15,000, we see he's already at his original position. At the actuarially fair premium, he's already indifferent. So if we look a bit ahead, he's not going to pay more than the pure premium. He's just not. It's going to lower his firm's utility. So he's not going to make the decision. If he did want to maximize it through insurance, they would have to offer something less than the pure premium. Unlikely that they will do that. It's unlikely. Again, we're ignoring, we know insurance companies can make investments. We know the insurance companies do operate at underwriting losses, okay, but we're assuming that out of the equation here. This is a one period, we have one decision. So, again, to reiterate here, for risk-neutral entities, insurance, in this way, insurance with any loading, okay, so to be clear, with any loading is a negative NPV project. It would not maximize utility. And that would dictate that in theory, firms should not buy insurance. And based on our assumptions, that's true. And there are some firms who don't. Or they create a captive insurer. And reap some of the benefits of that. However, some firms do purchase insurance. Some firms do purchase insurance. Why? This is not a collectively exhaustive list, but we will end on this. A few reasons. I'm going to discuss them quickly. The first one, which I think is easiest to understand, is managerial risk aversion. This just means that Ray, the manager of his firm, he's risk averse and he runs the business in the same way. That makes a lot of sense. It's kind of difficult to show empirically, but it makes a lot of sense. So the managers are just risk averse and they behave that way. Legal requirements. You have to purchase insurance. Kind of hard to skate around that. And in fact, this could drive a lot of it too, and it's easy to understand that. Maybe not quite so clear. It could be for marketing or branding purposes. So if you hire someone, say, to landscape, right? Or maybe you don't have time to cut your grass or something like that. They may oftentimes say, maybe on their vehicles, that they're insured. That way, if they cut down that tree and it falls on your house, why not have to call your homeowners? So it could be a marketing or branding thing. And then finally, there are arguments been made that if taxes are progressive, so it's not a flat corporate tax, if taxes are progressive, they impose a curvature on the graph of a risk-neutral utility function. So again, that graph of a risk-neutral firm or entity would just be a straight line. So we have wealth here, and then utility of wealth, where utility of wealth is just equal to wealth. So that's what it would look like. But if for some reason we have a progressive tax rate, which would, for firms, which would mean that they get to a certain point and they're taxed slightly more. So if they're taxed nothing from $0 to $100,000, and they're taxed 25% on 100 to 200, and then 50 above that, then at those break points, the dollars do mean less to them. Okay? So what that will do is, you have a really high slope to begin with because you're not taxed. Then there's a break point where you're taxed a little bit, and then another break point where you're taxed even more. Then we're kind of back into the realm of some curvature there. So these should, I'm not an artist, from points to points, these should be straight lines. But what happens is they go to that next tax bracket, and that next dollar is taxed a little bit more than the last, let's say, 100,000. Now we have a flat corporate tax. This doesn't hold true. Okay, but for individuals, it could, because for individuals, we are subject to progressive tax rates. So if you make $50,000 a year, your effective rate will be lower than someone making $150,000. Now they're still taxed the same on their first 50 as you are. It's progressive, so it's not like you go over that next bar and all your money is taxed higher. No, it's just everything above that point. But their effective rate will be slightly higher than yours. So the rate from 50 to 100 might be, 3% higher. And from 1 to 150, it might be 1 or 2 on top of that. So that's how taxation, because the corporate tax, or a progressive tax rate would increase at an increasing rate, which would mean that the dollar that you get back at certain levels is going to decrease at certain breakpoints. So it imposes that curvature. And then, maybe to circumvent some taxes, or defer, not circumvent, that sounds too nefarious, but defer some certain taxes, you would purchase insurance.